In this video, we're going to be calculating the spring constant from an oscillation graph. So determine the spring constant if the spring is 531 grams and its mass created the position time graph shown below. Okay, so what we can do is we look at two consecutive troughs. A trough is the lowest point, like that. So you're going to look for two consecutive ones. That's where the pattern will repeat. Now let's look at our graph. So we can see that our first trough is roughly at 1.8, and we can see our second trough is roughly at 5.8. So now to calculate the period, that's going to be 5.8, your second period minus your first period, and that's going to equal to 4.0 seconds. So now after this, you have to use the simple harmonic motion period formula. So T of the P, so this is going to be a spring. So you're gonna label this TS. There's also the period of a pendulum as well, which we label as TP. So that is 2 pi times the root of m over k. So after this, we're gonna solve for k. Okay, so you're gonna divide both sides by 2 pi. And then you have to square both sides. So this is going to give you after this, you need to get so now you have that, but what you want is that's going to be 1 over k, so you can just flip the whole fraction and then you will just get k. So now after this, you can plug in your values based off of what we are given. So we're given a 531 gram mass. In kilograms, that has to be your SI unit, so it's going to be 0.531. Now after this, we can plug in our values even more. So k is equal to 4 times pi squared. Our mass was 0.531, and we divide that by our TS. We got approximately 4.0 seconds, so that's going to be 4. And then we're squaring that, so that's going to equal to, if you plug this into your calculator, 1.31, and your units are going to be newtons times meters. Or actually, yeah, it's going to be newtons times meter, newtons divided by meters. So yeah, but usually sometimes it's going to be unitless if your answer option already has that included. You don't want to repeat your units. Okay, so now let's do our second question. Determine the spring constant if a spring of a mass. Okay, so this is not going to be 531 grams. This is actually going to be the graph that's generated for 808 grams. So let's do this problem. It's slightly different than this one because we can see that our frequency of our period is greater. So let's do this. We can look at our troughs. So we can see our first trough is approximately going to be 1.2 seconds. Our second trough is approximately going to be 3.9 seconds. And then now we had to, you can also look at your third trough as well. We'd say 6.6 seconds or 6.5. I'm going to make this look more like a 9. So now you can find your period. So you can take 2 consecutive. So 3.9 minus 1.2 is 2.77 seconds. You could also do 6.6 minus 3.9 is equal to 2.7, so you know that it's consistent. That's your period. So now after this, that's your T. So now you can use your period formula and you rearrange that. We already did that proof over here. So you can see here, that's your period formula. And then we rearranged it to get the K again. So yeah, you're just going to do the same thing. You're just going to keep plugging into here. 4 pi squared m. So with our values here, we have 4 times pi squared times our mass. Our mass is going to be in kilograms. So that's 0.808 kilograms, and 0.808 Here, now you divide that by period, 2.7 squared, and that's going to equal to 4.37. Now above, we could also calculate some other things. So if I want to show you how you get that kilogram, so you just know that it's going to be 1,000th of it. So because there's 1,000 grams in a kilogram. Now for your frequency for this, your frequency would have been 1 over t for this question that we did earlier. That is 1 over 4.15, and that would have equaled to 0.241. Now, for one period of the graph, yeah, we did that. So, yeah, we have that. And, okay, so for here, 4.37 Newton times meters is your K. And another way you could do this is that to do this faster, you know you have T is equal to 2 pi m over K. So you can just instead just remember to do K is equal to m times 2 pi f squared, or K is equal to m times 4 pi squared m f squared. And then if you plug everything in, it would be faster as well. Or you could do K is equal to 39.48 meters here, and divided by t squared, which is what we got up there. So now after this, let's do one more problem. So for our last question, we have 708 kilograms. Here we're gonna convert this into kilograms, so that's gonna be 0.708 kilograms. That's your mass. Now after this, you have to find the period from your graph. So you know that t is equal to 6.6 minus 2.0. That's equal to 4.6 from our graph, because we can see here that we have this is going to be, we're going to look at our consecutive peaks. Our peak here was at 2, and then we see our peak here is basically at 6.6. So that's how we get our t. Now after this, you can also get your frequency. Your frequency is 1 over t, and that's 1 over 4.6, and that's 0.217. Now after this, again, we use our formula that we got here for K, which we showed the derivation for. So after this, just plugging in, K is going to equal to 4 times pi squared 0.708 divided by 4.6 squared. Now, if you plug that in, that's 1.32 Newton meters.